Hello everyone, welcome to yourfaculty.com. We are going to deal with this topic, pipes and cisterns, in this video. Our website is yourfaculty.com and our Facebook page, search for Your Faculty. Okay, I'll try to give a quick brief on pipes and cisterns here. So, questions basically go around having a tank and there being a tap. So, the question will basically say that a tap will fill a tank in X hours. Okay, so in 1 hour, applying our time and work concept, what portion of the tank is filled? 1 by X of the portion of the tank is filled. Please understand, if a particular tap takes X hours to fill the tank fully, okay, at the end of 1 hour, okay, if this is X hours, right, at the end of 1 hour, 1 by X of the tank is filled. So the question can be twisted by adding one more tap. In that case, it's like two people working for the task. So at the end of 1 hour, it will be 1 by X plus, let's say the new tap will take, B will take Y hours. So in that case, 1 by Y is the total portion of the tank that is filled. That's it. Now, what is the other twist that they can bring in? This is Y, this is X. They can say that there is a leak or water comes out through this tap, right? So in that case, you need to, let's say, it can empty the tank. This tap can empty the tank in Z hours. In that case, in 1 hour, it will empty 1 by Z of the tank. And if all three are working together, what happens? It's 1 by X plus 1 by Y to fill the tank, and 1 by Z. This is emptying, so we are putting it putting a minus symbol here. So so what does this expression mean? In 1 hour, whatever answer you get over here is the portion of the tank that is filled. Okay. So what you'll do now is I'll start solving questions. So I think you'll be able to understand this concept better there. So remember, time and work concept, we are just trying to apply it over here. Two pipes A and B can fill a tank in 20 minutes and 30 minutes respectively. If both the pipes are used together, how long will it take to fill the tank? So it's a very simple question. So part filled by pipe A in 1 minute. I am taking in minutes because it's minute here. If it takes 20 minutes to fill the tank, in 1 minute, how much will it have filled? 1 by 20, right? Part filled by pipe B in 1 minute. If it takes 30 minutes to fill the tank, at the end of 1 minute, it would have completed, it would have filled 1/30th of the tank. Fair enough? So if both of them are opened, right? In that case, part filled by A plus B in 1 minute. How much would that be? 1 by 20 plus 1 by 30. Both of them are being opened. So we are going to add them because they are filling the tank. And what do you get? You get 5 by 60, which is equal to 1 by 12. So what is this? What does this mean? 1/12 of the tank is filled if both of them are open in 1 minute, which means it takes 12 minutes to fill a tank. That's the answer for you. A cistern can be filled by a tap in 4 hours, while it can be emptied by another tap in 9 hours. If both the taps are open simultaneously, then how much time will the cistern get filled? So again, very simple. you just need to remember that it takes 4 hours to open to fill the tank, and when emptied it takes 9 hours by another tap. So in 1 hour both of them A or okay both the taps are open. So what is the net part filled at the end of 1 hour? It will be 1 by 4 minus 1 by 9. Remember, we are putting negative sign here because this tap is emptying the tank. Okay, so 1 by 4 minus 1 by 9 is equal to 9 minus 4, 5 by 36. So we know that 5 by 36 of the part, 36th part will be filled at the end of 1 hour. So what is that we need to find out? If both the taps are opened, how much time will it take? So the time taken will be this is the part that is filled in 1 hour. So total time taken will be the reciprocal of that 36 by 5 hours, which is what? 7 by 2 hours. So moving on to the next question. A tap can fill a tank in 6 hours. After half the tank is filled, 3 more similar taps are opened. What is the total time taken to fill the tank completely? Okay. So we know that a tap can fill a tank in 3 hours. 6 hours. So total time take after half the tank is filled. So half the tank is filled in 3 hours. Remember, it takes 6 hours to fill the tank. So in 3 hours, half the tank is filled. So what is the next thing? If 3 more similar taps are opened. So if 4 taps function together, what do we get? If one tap can fill in 1 by 6, can fill 1 by 6 of the tank in 1 hour, 4 taps can fill into 4. 4 by 6 of the tank in 1 hour. Right? And what is 4 by 6? It's 2 by 3. So we have already filled half the tank and we are left with half the tank. Right? And as per if all the 4 taps function together in 1 hour, they fill 2 by 3rd of the tank. Okay. So what is that we can do next step? The next step is, in that case, if it takes 60 minutes to fill 2 by 3 of the tank, right? What is the time taken to fill half the tank? As simple as that. Now apply our shortcut technique. We need to cross multiply, and wherever there's a question mark, that will come into denominator. So 60 into half by 2 by 3. So what do we get? This 3 comes up. 15 threes are 45. So for all the 4 taps function together, it will take 45 minutes to fill half the tank. Fair enough. So that's what you have done here. So 45 minutes plus 3 hours. So the answer is 3 hours 45 minutes, because 3 hours for one tap to fill half the tank, and 45 minutes if all 4 taps are opened. A water tank is 2/5 full. Pipe A can fill a tank in 10 minutes. Pipe B can empty it in 6 minutes. If both the pipes are open, how long will it take to empty or fill the tank completely? Now, pipe A can fill a tank in 10 minutes. Pipe B can empty it in 6 minutes. So what does this mean? At the end of 6 minutes, B can actually empty the tank. So which means emptying is faster than filling, right? So pipe B is faster than pipe A. So which would mean we need to find out not fill the tank, but how long will it take to empty the tank. That should be our approach. Okay, so if both pipes are open, how long will it take to empty or fill the tank? So the tank is, okay, this is very key, 2/5 full. So tank is 2/5 full. Okay, so if it has to be emptied, how much should we empty? How do you arrive at it? See, technically, the moment in 1 minute, there's no water in the tank if we do the calculation over here, because pipe B is faster than pipe A. So which would mean we are technically left with 2/5 of the water to be drained out. So please don't worry too much about that microsecond calculation of how the water will fall and when it goes out. The question here just tries to say that, okay, uh, you are 2/5 full and it takes 10 minutes to fill the tank for pipe A and 6 minutes to empty. So technically, if you're not taking into nanoseconds into consideration or whatever it is, we should be emptying 2/5 of the tank, right, at any point in time. So what is the part emptied by A and B together in 1 minute? How do you do that? It's 1/6 minus 1/10, right? So 1/6 being the highest, that's the speed at which it will empty, and this is the speed at which it's getting filled. So A and B are working together now, and hence one is emptying and one is emptying and one is filling, and hence there's a negative. We are subtracting it, and what do we get? 10 minus 6, 4/60 is equal to 1/15. So it takes 15 minutes if they are working together. 1/15 of the part is emptied in 1 minute. Okay, so 1 minute, 1/15 of the part. And what are we supposed to find out? 2/5 of the part? 2/5, how much it will take to empty 2/5 of the part? Question mark. So we know that we need to cross multiply 2/5 into 1 by 1/15. Wherever there's a question, remember, please write it like this so that it's easy. Please make sure you bring the similar kind of units together on one side. So it is 1/15 here, 1 minute 1/15, x minutes 2/5. So we just need to put 1/15 over here and bring 15 up. 2/5 into 15, which is equal to 6 minutes. And what is that? 6 minutes to empty. Okay. 3 pipes A, B and C can fill a tank from empty to full in 30 minutes, 20 minutes and 10 minutes respectively. A, B and C discharge chemical solutions PQR. What is the proportion of solution R in the liquid in the tank after 3 minutes? So what are they trying to say? Let's try to understand. There is a tank and there are 3 pipes. Okay. So A, B and C. And what do? They fill this tank with P, Q and R, the three chemical solutions. So they say that one separately takes 30 minutes, 20 minutes, 10 minutes. Fine. So all three of them work together, are open together for 3 minutes. So at the end of 3 minutes, let's assume that it fills this portion, right, to this level. All three of them together. So what are they trying to say? They are asking us what is the proportion of solution R in the liquid. How do you find that? It's pretty simple. So what we need to do is we need to first find out the total net portion that is filled at the end of 3 minutes, right, when all three taps are open. And then also find out the portion filled if just C is open for 3 minutes, right? If we have both these values, then it's all about taking the ratio. And the ratio, we'll see it in the while we solve it now. Okay. So in 3 minutes, part filled by A and B and C is equal to, how much is that? 1 by 30 plus 1 by 20 plus 1 by 10. See, we know that this is for 1 minute. Now it's for 3 minutes. We have to multiply this value by 3. And what do we get? We can take 60 as common here. So we'll do 2 plus 3 plus 6 by 60. 9, 10, 11. 11 by 60 into 3. So it's 11 by 20. So this is the part filled when all three taps are open. Now if C alone is open for 3 minutes, we know that for 1 minute it is 1 by 10. For 3 minutes it is 3 by 10. As simple as that. So what is the proportion now? Proportion of R is equal to, what is the portion filled by pipe C? 3 by 10, and portion filled by all the pipes together, 11 by 20. And solving this, we'll get the answer. It's 6 by 11. That's the answer for you. Thanks for watching our video. You can subscribe to more videos at your faculty channel. Like us on our Facebook page and our LinkedIn page, and you can also follow us on Twitter. Thank you.